When a fella gets deep into blacksmithing, one of the most impactful tools he can get is a hydraulic forge press. But when you look at buying or getting one of these machines, you quickly realize that in order to unlock the full potential of the machine, you either have to buy or make a lot of different dies. Dies are an interchangeable component that goes into the machine. Specific dies can be used to forge different shapes or forms into hot steel. You can see that I already have a lot of dies for the 16-ton press. So in this video, I'm going to cover making some dies for the 24-ton press, hopefully saving a lot of money in the process. Hey everyone, thanks for stopping by. I'm Enzo Greymane with Night Owl Forge, and I'm really excited to get working on these dies. I got the 24-ton press about a year ago, but because I've been so busy building the new shop and kitting it out, I really haven't had a chance to use it at all. And I've been itching to make swords in Damascus real bad. So creating these dies is going to be a big and hopefully one of the last steps to get me there. Dies come in sets or pairs where you have a top die and a bottom die. Each die generally consists of 3 components. You have the die plate, the die tab or block, which has a hole or notch in it for attaching it to the machine. And the third thing is whatever you put onto the die to shape the hot steel. The first steps of this project are just about the first steps of every fabrication project, and that's cutting and grinding a lot of steel. Here we have 6 half-inch thick steel plates. These are 6 1.5-inch thick steel tabs, all of which took quite a bit of time to cut and grind, probably 5 or 6 hours total, because I wanted to make sure that all of the angles were either perpendicular and we had everything parallel, and that all of the edges and corners were rounded down and smooth. All of this combined is going to give us 3 sets of blank dies. On the anvil, we have the odd-shaped pieces of metal, which we're going to weld onto the blank die sets. These are laddering dies, which are used to make ladder pattern Damascus. These are squaring dies, which is used to square up stock, which is also really good for Damascus when you want to make C or W patterns. And over here we have the combination dies, which are a combination of fullering dies and flat dies. The fullering dies are used to draw out thick stock like Damascus billets. And then the flattening dies, or the flat dies, are used to flatten down whatever you drew out on the fullering dies. One thing I gotta do before I start assembling these die sets is heat treating these blocks and half-round pieces of steel. I actually did it last night and got it on film, but somehow I lost the footage. So I'm gonna do it again. It doesn't hurt to normalize steel a second time or harden this air hardening steel a second time. These blocks are 4140 that I forged, and when I was cutting and grinding them, I discovered areas that had larger grain structure that I wasn't happy with. So I was gonna address that by normalizing them, which entails heating them up to a nice orange glow and then cooling them down somewhat rapidly. We don't wanna quench them and harden them, but cooling them down fairly rapidly is going to retain the small grain structure throughout that process. The process is going to start with letting them cool down in the air to a nice dull red, almost not visible heat. And then I'll place them between 2 large pieces of steel, which will draw the rest of the heat out. That process of normalizing the steel and getting the grain structure down is going to go a long ways in ensuring that the surfaces are as hard, durable, and wear resistant as they can be while forging. The H13 half rounds came in 1 large piece, and generally when you order steel like this, they send it in a soft state. That way you can cut or machine it to a desired dimension or size. You can see here that I've already cut it in half, so I want to harden these, that way I can get the surfaces more durable for forging. Because H13 is an air hardening steel, the process is simple. We just heat it up to a nice orange glow and then set it to cool down in the air. That's going to harden the steel, giving us a nice durable, wear resistant surface. We're now at part of the process where we need to start putting these holes or notches into the die blocks or the die tabs. These notches are what help secure the die plates or dies into the machine. The machine has a swivel head bolt that when you tighten it down, it pins this part of the block into the machine. If you look closely, you'll notice that this notch has a flat bottom to accept that flat swivel head, and that it's also angled, which when you tighten it down will apply force downward, sucking the die down into the machine. It's a really good system, and if you look closely at the notch, it looks like they inserted that into these tabs using a mill. I don't have a mill in the shop, so I figure out a way to do it with the drill press. It's a bit janky and a kind of sketchy in some ways, but it's pretty simple. We just use a 3/4 inch drill bit to start a hole, and then I swap over to a 3/4 inch flat bottom end mill and kind of use the drill press as a mill. That'll get us a nice flat bottom tilted notch in there that will help secure these dies into the machine properly. The milling process was a success, and we have notches in all 6 die tabs. We're almost ready to start the assembly of the blank dies, but there's a few small things left to do. One of the small things I need to do before we start assembly is grinding away some of the mill scale from these plates. That way we're going to get the best weld that we can, which is going to be really important on these welds. On the 16-ton press, I've had these tabs break the welds before. It's not like a tragic event and no one is at risk of injury, but we want to avoid that. And when you weld stuff that has mill scale on it, that increases the chance of things like impurities and porosity in the weld. So I'm just going to take a tab, put it down on here to get a rough idea of where it will be. And then I'm going to mark the area that we're just going to grind away a little bit. The last minor thing I had to do before we can finally start tacking and welding these things together is mark them up. That way we could center the tabs on the plate and make sure that everything was aligned. We got some center lines for visual reference and some guidelines to center those tabs. Let's get to welding, finally. Welding these is going to be really straightforward. I'm going to crank the welder up as high as it will go because this is very thick stock. But other than that, I just need to weld 2 joints, both of which are fillet welds, which are probably the easiest joint to weld. I'm going to start by clamping this all down to the table, putting a tack on both sides of the tab, and then putting in my final welds. It might be kind of hard to see on camera, but welding these really big welds here put a lot of heat into this piece, which has made it kind of cup this way as a result of all that heat and cooling down. So in order to address that, I figured out a simple way. We're just going to load these blanks into the machine. And then we're going to put this large round here, which is just going to push the middle down, which should hopefully get that little bit of warpage out. All right, I can see looking here that there's no air gaps, so it looks like we got all that warpage out of those plates. I spent a decent amount of time getting the blanks ready. I ground off some of the mill scale here where we're going to weld these odd shaped pieces of metal onto them. I also wire wheeled all the welding, splattered things off from the underside, and then I marked them all up to where I want these pieces of metal to be aligned. One of the benefits of making your dies or your own die sets at home is that you can align them perfectly in your machine. If you buy them from the factory, while they might align them there to some degree, the actual die might not fit in your machine perfectly aligned. What I'm going to do is tack up the top side here by using my guidelines, and then I'll put this in the machine, lower that down to the bottom blank die, put the block in the bottom die, and then tack that in. That will make sure that these blocks are perfectly aligned within the machine. So I tacked up these half rounds yesterday, and after doing a little bit of testing and looking at it, I wasn't super happy with the alignment. And getting the alignment on these half rounds is very important, because if they're misaligned in any way, the bars that you draw out in here will tend to banana in either a left or right direction, or they'll curve downward or upward. And it's kind of a pain, and I've experienced it on other fullering dies. So I was trying to brainstorm a good idea of how to address this, and after going to the gym last night, I had the idea of why not just 3D print a jig that I can just set in here, and it will align these half rounds together. I can just lower this top one down onto there, and it should just kind of get it nice and centered, and we can tack it in. Now that all three sets are all tacked up, we're ready to pretty much start welding. The laddering dies are made out of mild steel, so we can pretty much just weld those and call that a day. But these four here have either high carbon or medium carbon alloy steels on them. And when you go to weld that to the mild steel die plate, you can create some issues. The main thing is that you're trying to weld two different types of steel that handle heating and cooling differently, and you're melting them together. So that can create a region that is brittle and will crack and making the weld fail. So there's a couple ways to address that, but the easiest way to address that is by preheating these. I'm going to set them right outside the door of the forge. We're going to get them up to about 400 or 500 degrees and then weld them. That will make it so there's not a huge jump or variance between temperature, and that will make the welds mellow out a little bit. After we're done welding it, we're going to put them in some fiber blankets that will allow them to cool down a little bit more slowly, which will also kind of relieve some of the stresses of welding. I've pulled the dies out of the fiber blanket and kind of done a little bit of an inspection on them, and I'm really happy with the results. All the welds look really good. I haven't seen any cracks or deformations in them, so it seems like everything held up through the cooling process. I'm also really happy with the way the colors are displayed on these dies. Those are tempering colors, and those show up when you heat up steel to a certain range of temperatures. And it looks like, based on the colors I'm seeing, that these dies didn't really exceed about 500, 550 degrees. That's really good because it means that all of the heat treating I did beforehand has been preserved. They haven't gotten too hot and soft. So these should be durable and tough and last a long time while forging with them. I've already cleaned up these laddering die welds. I'm going to do the same with these other 4 here real quick, and then we're going to get to squishing. Thanks for joining me in this process, and I just wanted to quickly point out that a set of these combo dies from the factory is about $850. The squaring dies are about $500, and these laddering dies are about $450. So in total, we're looking at about $1,700, $1,800 in dies, and that's before tax and shipping. My investment was about a quarter of that, so I saved a lot of money, but I also ended up with dies that not only did I create, I was able to align them in my machine so that they're the best functioning that they can be. I hope that you can see that whenever I make something, even if something like as brutish and simple as these press dies, that I put a lot of time and consideration into the details. Those small details really add up to make a final product that is really well functioning and looks amazing. Whether you know me as Enzo Greymane, the Wily Wizard, or Night Owl Forge, you can always count on me to put way too much time into a project. Until next time, keep forging, keep pressing, and stay inspired.